Welcome to the Weekly Squeak, your weekly geeky squeak with me, Christian Schiller. I don't know about you, I'm losing track of time right now. I don't know if it's been a week since the last episode. I don't know what week it is. I don't even really know what day it is most of the time at the moment. Easter holidays did not help, or did help, I don't know. Anyway, I'm sure you all feel much the same. Time is getting squishy and wishy-washy and hard to comprehend. Anyway, let's carry on with the Weekly Squeak. I have an interview with Chris Longstaff of Mindtech in this episode, and I've got a handful of links for you and a few bits and pieces of news. So let's jump straight into the links. This is not a new article. I don't always mention new articles. I mention things that have sort of crossed my plate, come across, that have interested me as I've been researching other things. So this is an article from The Guardian from last year, from Stephen Poole, about robot authors. I've been looking into this because I had a strange idea with my wife, I'm not sure, probably a year ago now, when she mentioned some of the books she reads, and to me they sounded very formulaic. And I said to her, kind of jokingly, I think surely a good computer could write those. It's basically like plug in these various variables and then just write the same thing each time. And of course this was also in 1984, and I think probably some other dystopian books as well. And it actually got us both thinking, could we do this? Could we write like a sort of mass market romance book with an AI? And we'll be doing some digging into this subject. And actually I came across a few things in this week that were sort of going into this, and some of the playgrounds where you could actually experiment with getting an AI to finish sentences for you and things like that, which isn't quite what we were doing, but it was sort of an interesting experiment to see how possible it was. And this article refers a lot to the GP2 library put out by OpenAI last year, and then who withdrew it again. And strangely, one of the playgrounds I found was using it. I don't entirely understand how they were using it if it isn't available, or there's a subset available, or it's slightly confusing to understand exactly what it is, because sometimes you sort of get into reading somewhere between very high overview think pieces and then really in-depth pieces about natural language processing, and sometimes not a lot in between. So it's hard to know exactly what you're reading sometimes. But this article is very much a high-level overview of what is possible. There are already some robot authors used in some journalism, especially highly statistical journalism like financial reporting or sports reporting. And definitely writers are already using assistants like Grammarly and things like that, which do not write for you, but they prompt you to change your writing in certain ways. And I've always wondered about how they are affecting your writing. I actually did a presentation on this subject last year, the year before last, at SoapConf. There is a video of it, so you could dig that out. I'll try and find it and add it to the notes for the show. But yeah, it was an interesting article that had a few good links out to some of the things I then dug into in a bit more detail. So if you want to find some of those yourself and have an explore yourself, then have a look, see what you come up with. Send me the links of what you end up, or what your AI ends up writing for you. Now, an article from Wired by Manuel Midolo. This is, I seem to have what I should call SoftBank Corner on the podcast. Well, this is specifically to do with WeWork, which, maybe also we need a WeWork Corner. Don't blame coronavirus for WeWork's collapse. Blame WeWork. WeWork is collapsing, maybe. I don't know. I haven't really heard any confirmation of this, but this article implies they are. Obviously, co-working is not a business model that is working very well when no one can use it. And lots of people are cancelling memberships of co-working. I know from some of the staff at co-working spaces here in Berlin that is struggling. It's very difficult to replicate what they do, and people are cancelling their memberships. Corporate offices are cancelling their memberships, which is where all of these places actually make their money, etc., etc. It's quite a hard time for co-working, especially if you are a co-working space propped up by a lot of money from an outside investor that has never been profitable and has a lot of very expensive real estate. So I think WeWork are trying to blame coronavirus, but their problems were already there, of course. We knew about their failed IPO and things like that. They're using it as an additional excuse, but it's not the beginning of their problems. And this kind of is exacerbated and summarized in news from April the 1st, so 2 weeks ago, that SoftBank decided not to buy $3 billion of their stock, dealing a blow to shareholders and also dealing a blow, I guess, to confidence in the company. And I have seen articles coming up the past couple of days showing that SoftBank are equally finally hitting financial troubles. And I was wondering how long that would take. If you are regular listeners to SoftBank Corner, because they're an investor who is constantly, well, not constantly, but regularly invested in companies with large amounts of money that are not profitable. So there will come a point where that will become a problem. And yes, it looks like that problem is coming. What will happen to Uber? I have seen lots of Uber cars driving around, but I don't know how many people are using them. So they may start getting hit by very similar problems as well. Now, this is an old article, nothing new at all, from, I doubt, a blog that I've ever featured on the Weekly Squeak. Listverse.com. I think it was just a good summary of what I wanted to discuss. This is something by Elizabeth Anderson called 10 Bizarre Calendars from History. This mostly came up and why I started looking around the subject, because after a conversation with a friend, he mentioned the International Fixed Calendar, a calendar that has 13 months. First proposed by a worker from the British Railway, but actually popularized by Kodak Eastman. They actually, I have to go and find the number here. For nearly 70 years, Kodak actually operated on this calendar right up to 1989, and probably did a lot to popularize it. But one of its main problems, so actually I should explain what it is. It has 13 months, each have 28 days. So it's very easy to kind of know how many days in a month and et cetera, et cetera. But the problem was, of course, lots of public holidays would have to shift. And this is what most upset people. And as with any alternate calendar, and of course there are 9 more in this article, there are problems with communicating with the outside world. And there are examples of this in various ways, like the Japanese have their own form of calendar. The Jewish world has its own form of calendar. The Arabic world has its own form of calendar. There are actually many alternate calendars in partial use, but generally people also recognize another calendar, the calendar that most of the world uses, which is the Gregorian calendar. And the interesting thing to note with especially the Gregorian calendar, but other calendars, is, as is often the case with things from history, it's maybe not as old as we think, and it was not always used. I suppose as global trade became more and more important, it was more important to solidify around one thing. But there are still definitely alternate calendars used by lots and lots of people. And depending where you'd go in the world, they would possibly be very confused by you referring to the date as whatever the date is today, something in April 2020. They might think of it as something else. And this is quite an interesting article to look at some of those alternate views, some from history, some not so old, and what the various positives and negatives about those calendars were. What's your favorite calendar? There's a question for you. And now an article from the MIT Technology Review by Will Douglas Heaven. I'm sorry, I was trying to avoid the subject, but I'm mostly skirting around the edges of the subject. Why the coronavirus lockdown is making the internet stronger than ever. I think a lot of people thought the internet would really struggle with so many people working from home and streaming. And granted, to begin with, it did. But it has mostly stabilized, I think, through various measures. It depends where you are in the world, of course. But actually, this connects nicely with something I've witnessed happening around Berlin as well, in that it's kickstarted a needed upgrade to certain bits of infrastructure too. Companies are rolling out upgrade programs that were probably scheduled, but are now kind of needed more than ever, and helping keep things going. And also doing compromises, like, for example, with lots of the streaming services saying to the European Union that they would reduce the stream quality from 4K, because you could argue, do you really need 4K anyway? So it helps everybody. And this has been interesting to see. As I say, this is something I have noticed happening in Berlin on the physical, well, the internet is obviously physical, but in something you can see, I've noticed lots of building projects really rapidly getting completed. The workers are still working there because there's less people in the way. I've noticed various infrastructure upgrades to the public transport system here, building sites getting finished much quicker because there's less traffic, less public transport running, less people around. So strangely, whilst we're all not using it, the world is getting upgraded around us, again, depending where you are, I suppose. And the same thing is happening to the internet. And this has often been through statistical analysis. So some of the various companies involved in keeping infrastructure going or providing infrastructure are noticing when spikes are in certain parts of the world and shifting resources around to help. And this is something they've always done, but they're doing it on a much larger scale and on a different scale. For example, the traditional centers of some cities where business was happening are obviously not using much capacity right now. In fact, they're probably using very little, whereas in the suburbs of some cities, people are using more now. So they've shifted around a lot of the capacity to match. And this actually relates a lot to the initial structure and design of the protocols that run the internet. It was supposed to be flexible, and it's showing that it actually works quite well, this fairly old technology. So it's good to hear there's more life yet, and we will all be allowed to keep streaming our meetings for who knows how long. Anyway. All right, now here is my interview with Chris Longstaff from Mindtech. This was an interesting company, as you will hear. But Chris was basically trying to show me a presentation as he talked. And I don't know how much this comes, well, it's going to definitely come across in the interview. I tried to edit it a bit, so it doesn't sound quite so much like that. But he does occasionally refer to things that obviously you can't see. And I will find out if I can provide the presentation in the notes. And so you can refer to some of what you're referring to. But I hope there's enough left in the audio that you understand what the company is trying to do, because it was quite fascinating.
So I'm Chris Longstaff. I'm the VP of Product Management for Mindtech Global. And so I'll take you through today a little bit about our product Chameleon and talk through that. Basically, Mindtech's a UK-based startup. Founded in 2017, though really started working in 2018. And we're really all about producing solutions for AI, particularly the tool chain that we'll talk about today for synthetic data generation, and focusing obviously business to business markets, rather than directly to the consumer. Very experienced team you'll see there in terms of both the leadership and the board of directors. Obviously, in terms of target markets, because of what we're doing, it's fairly broad. We're really talking about synthetic data, generating the data that I'll talk a lot about. So really going across a large number of markets, though focused a lot at the start on smart vision. So particularly in terms of retail, and in the sort of the safety and security parts of those markets. Obviously, for any AI system, there's a few key elements to that. There is the architecture itself, and obviously these have evolved rapidly over the last few years, and we have different architectures, going from AlexNet, GoogleNet, through to more modern ones, so ResNet, VGG, all these kinds of different networks. Most of these will be obviously developed under some sort of framework, TensorFlow, PyTorch, and so on. But in order to make that do anything useful, obviously we've got to train it with a huge amount of data. And as the famous quote from Andrew NG says here, it's all about the data. And really what we're trying to do is get these machines to understand, and to do that, they need labeled data. I mean, it's an interesting question that we get asked by our customers is, well, how many images do I need to train a network for certain things? And obviously it's not all about the quantities. It's about, are they the correct images you've got? And there's a few examples here, in the automotive world. If you've recorded lots and lots of straight roads, then that's great. But when you come to something like what we have called the magic roundabout in the UK, which is one big roundabout with 5 smaller roundabouts around it, anyone who's not, a fairly experienced driver and understands roundabouts will very quickly become confused in that.
Yeah.
We have this concept as well of data drift. And what we mean by that is that, the requirements for data change over time, sometimes more rapidly, sometimes more slowly. But, the example there, wristwatches, obviously they've changed over time. So if you're trying to recognize a wristwatch, then training something on pocket watches isn't going to give you the right results when you're trying to look for an Apple smartwatch. And again, understanding a scene can be very, very tricky. That first image there, is that people fighting? Are they dancing? What's going on there? Will your camera recognize that in the middle as a pair of cows, or does it recognize it as the advertising poster on a bus? So the problem here is obviously that we need to have data, and we need to have, as I said, a lot of high quality data, and we need access to that. And there's very, very few companies who have access to those very large amounts of data. And even those that do, it's perhaps questionable as to their rights always to use it. And certainly those that do mostly don't want to share that data. Several key issues that we'll sort of cover about, how synthetic data can help overcome some of these issues in terms of real data. But real data is very expensive to get hold of. So if I go out and record things, it's very expensive, takes a lot of time. Real issues around privacy, and particularly, with respect, obviously, facial data is very common, but even things like seeing vehicles and having vehicle license plates stored can be a key issue for anyone whose system is hacked and has, this kind of data stored. Getting that data not to have bias in it is a very, very difficult problem. And that is where, having a very, very broad spread of data is critical. Getting the annotation accuracy, very, very hard for real data and very, very expensive. And the more accurately you want to annotate something, the more it is going to cost you. Yeah, what's our solution is synthetic data generation. And, the way that we do this, we create a virtual world, whether that's a hospital, like the image in the top right there, an underground station. We add the assets that we're trying to look at in there. So that's the cars, the people, and so on. Configure times of day, global variables like weather, and so on. We then effectively film this. And so we create a virtual film. And obviously, because we've created that virtual film, we have a full understanding of what the objects are. We place them in the scene so we can create the output masks and so on. And then we have a full tool chain to manage that, to manage the data that we've generated. Huge number of advantages to using synthetic images and data. I'll talk through a few of them in a bit more detail. I've mentioned some already. Fast creation of very large data sets. The adaptation again there to drift data, obviously very topical at the moment. Coronavirus, how do we adapt things which may want to check for things like people wearing face masks? Getting that corner data, so a drone over an airport, can be very, very difficult to film in real life, but we can create that kind of corner data using synthetic images. We can rapidly change any environmental conditions, so we can view the same data in different conditions, and we can do that effectively instantly. We have many different kinds of sensors that we might want to model, so not just necessarily RGB cameras. We may want to model LiDAR, we may want to model radar, as well as the traditional RGB sensors. Multiple cameras at the same time. Clearly, you can do this in real life. It's actually very, very difficult to synchronize the cameras and make sure that you're looking at the exact same data at the exact same time. And tuning those images, so you see an example there of a fisheye type lens, and making sure that we can match that to the system that's actually going to be used for the inferencing is very, very important. So slide 14, quite a detailed slide, shows effectively, what's our platform and solution. Comes in a number of different elements. The key in the middle there, so the tool chain that we have in the middle. So we have the scenario editor and asset importer, which we'll talk more about, the simulator and the dataset tools. At the top, we have a number of what I would call sort of creative elements, which are what are going to configure the scenario for us. So create, if you like, the film set and put the actors into that film set, model exactly what cameras we're going to do, and then we generate that data. And those data set tools then are going to take our data, they're going to take customer data, merge in real images, and then go through that standard neural network framework to create the trained network. All the time, though, what's important is, at the bottom left-hand side there, customer use case. So we have to keep bearing in mind, well, what's the end objective for this? What's the customer trying to do? Are they trying to create a pedestrian detector? Do they want to try and identify animals because they're causing false positives on doorbells? All these kinds of things. So that customer use case is critical. That is if you like, the cornerstone of everything that we're doing. So just a little bit about how we go about creating these things. So we've created a scenario editor. The reason for this, obviously, we don't expect that the data scientists who we're working with are 3D experts. The data scientists are there to work out the algorithms, work out what kind of training data they need, but we're not expecting them to be the 3D experts. So we create the application pack. So that's including the scenes, the actors, various different objects we might want to place into that scene, and then have a full UI for a scenario editor where we can effectively drag and drop the different elements with a real-time preview. So the data scientist can say, okay, I see what I want to see here. I want to check that the people in this office are perhaps wearing face masks because that's the new policy. And so they'll see real time how this is going to look on the film, and then they can use that to effectively create the whole film set with actors and visualize that before going ahead and running the simulation. We then send that scenario definition, so including all the details of the scenes, the assets, the locations, all the behaviors to the simulator. That's going to create a number of outputs for us. So whether that is, it'll create the visible image. We may want that visible image to be in Bayer space rather than RGB. We might want additional data like LiDAR and range data. We want some mask data. So we want, obviously, individual objects to be identified. And one of the key things about synthetic data, as I've mentioned, is that we can uniquely identify every single object. So in that instance there, you can see the pedestrians are identified. Actually, every single pedestrian there has an individual ID. So if we want to do re-identification, for example, we can do that quite easily because the same pedestrian will be always identified with the same ID. If you're using real data, it's very, very hard for someone to re-identify what a single pedestrian is doing, particularly if it's sometime later. If it's someone's gone off screen for 10 minutes in a retail environment, then coming back 10 minutes later and work for that person to annotate that that's the same person, that's exceedingly difficult. There's, of course, other advanced annotations that we get, things like velocity vectors. Again, from generating those from 2D data is virtually impossible, as is things like 3D bounding boxes. Very, very difficult to do in a traditional take a 2D film of something and then annotate it by hand. Of course, it's very, very important that we have great results from this. We have a couple of examples here of it working. The first one is actually a third-party paper that we wanted to share just to show that it's not just Mindtech who believe in this technology. And what we see here is that there's a training done either with a synthetic only, real only, or a combination of the real and synthetic. So what we see here is that the number one there is basically synthetic only. We see we get very, very good results from that synthetic data. And in fact, a lot of customers are coming to us because they have an idea, they think that they might want to do something, but investing in recording real world data is very, very expensive. Yet being able to prototype using synthetic data first makes a lot of sense. And you're not going to get the ultimate accuracy from that, but it at least gives you an idea of whether your algorithm can work or not. Over on the right hand side there, we see that with a big real world data set, we get the best results when we combine that with the synthetic data. So that bar under 3 there, that's showing that we have the best possible accuracy using a full synthetic data set and full real data set. What we also see is that in the middle there under 2 is that actually we could compile a smaller real world data set, augment that with the synthetic data, and we'll end up getting a result which is actually superior to spending all that time and money generating a huge real world data set. So, synthetic data may well get us much faster to market because after a shorter amount of time collecting real world data, augmenting that with synthetic, we're going to end up with some very good results. And this one's one from our automotive pack here. And what we've done here is use the kiddie data set, and we've augmented that again with our own data here. So from our simulator with a city scene with cars and pedestrians, and we see that the accuracy in the improvement in detection accuracy for cars goes up 6.9% and for pedestrians up 8.4%. So quite a significant result in terms of the improved accuracy. There's another couple of critical things that we can do with synthetic data. I've mentioned this one before. So basically optimizing for the deployment system. So what we do here is obviously we generate what we call gold data. So that is a very clean image. Now, at the end of the day, what is going to be used by the deployment system might look very different. Obviously, in the example there, it's a severe fisheye lens that's being used. It could be a very noisy sensor and so on. We have the gold data here, which we can then augment and modify by the customer-specific system, which means that when the system is actually deployed, the training data that's being used represents that deployment system. That's also going to optimize it. So if you change sensor manufacturers, lens manufacturers halfway through a run, you don't have to throw away your algorithm. You just have to augment and train with that new data based on the new camera system. So, just an example here showing, 3 different cameras, fisheye, black and white, very low cost, noisy camera, and each of these can be modeled using that very, very same golden data, but it means that the AI system is going to be optimized for your deployment system. I've mentioned this before, but obviously we have a very flexible approach to cameras. We can have multiple cameras together. These cameras can be visual cameras like RGB cameras, but also things like a LiDAR camera, a radar camera, a thermal camera. So effectively, from the same position, we can create that multiple cameras, and we can automatically then synchronize all of those. So if you're trying to train something to understand what the world looks like from multiple different cameras, then you have absolutely synchronized data sets. One of the other key things which is becoming very important, we see that within the world of AI, and particularly with ethics, and for things like automotive, it's very, very important to be able to show where your data has come from, so how you created that. With our Chameleon system, well, we have effectively a tagging system which gives provenance tags, which enables anyone to be able to go back and show, well, this is the exact data that was used to create that training data, which was used to train that AI system. So we can basically tag all of the data, and even if it's augmented and so on, we will tag that data, so that as we have the data pack library with all of the images, masks, annotations, that's effectively all tagged with the provenance and the source, so that later on you can go back and show exactly where that training data came from. And as I say, for something like automotive, that's critical to be able to have that provenance. I've mentioned already data drift. Obviously, some things, there's new use cases comes along where we need to react very fast, and going out and filming and generating that new data is very, very difficult and very, very time consuming and expensive. So something like coronavirus here, we can create a synthetic data masks. We can then create the virtual objects, so that for new use cases, perhaps it's monitoring how many people in a queue are wearing a mask. Perhaps it's making sure that tables in a restaurant are regularly cleared. Perhaps it's trying to look at re-identification of people to understand, okay, who's repeat buying, and where there's restrictions in terms of purchases. So something like synthetic data can help us react much, much more quickly than we would be able to react if we were relying on traditional real data. So some more benefits, which I've already mentioned a little bit, but certainly things like bias reduction. And bias can be anything. So anything which causes a data set not to have a balance in it. So it could be that perhaps all the faces are taken from the wrong angle. Obviously, with synthetic data, we can repeatedly rotate the face, generate images from lots of different angles to help train that data set. I've mentioned privacy. It's clearly a big issue for training data. And again, alongside the provenance that I've just talked about, this data privacy here, using synthetic data allows us to generate scenes without the risk of people or businesses becoming concerned about the privacy issues. Again, mentioned this case already. So the drone in an airport, if I really want to understand that, is it a bird, is it a drone, and I'm trying to create that data set, then there's no way that this could even be filmed in the real world. No one's going to allow me to film drones near airports. It will be very, very dangerous. So we can create those synthetic data cases for those difficult corner cases. Again, I think I've mentioned most of these, the advanced annotations that we can get. So basically it allows new use cases. So if you have something, a time of flight sensor, which perhaps can measure, create point clouds, measure velocities and so on, we can use that in conjunction with visual cameras, and the synthetic data can provide us training data for that to teach AI systems, new algorithms and new use cases that with manual annotation we just couldn't achieve. And then just lastly, obviously, the whole of our simulator is designed to be very, very scalable. So we've done some work with multiple companies, but AMD in particular, on ensuring that we can scale across multiple different CPUs, GPUs, to make sure that our Simulator is highly scalable, so where you want to generate massive quantities of data, we can generate that data very, very efficiently by using all available compute resources.
So the synthetic data, where does it come from? Is it from your libraries, or do people create it themselves?
So if I go right back to probably this diagram here, or maybe actually this one here, what we do, so we would get some scenes. So the buildings you see there in the application pack, maybe if I can enlarge that a little bit, it probably doesn't look great, but I don't know if that shows enlarged view, but we create that scene. So that scene there would basically be a 3D object, and we would get a graphic studio to create that for us. So we're not artists, so we get a graphic studio to create that for us. Similarly with the people, the objects, all of those kinds of things, we would get a studio to create that for us. And then what we do, so like the scene that you see here, we would, using that scenario editor, that's where we place the people in the scene, we place the items in the scene, and the camera in the scene there, so that we're then determining, okay, how are we going to effectively generate images from this? So it's effectively like, think of it as a virtual film set. But we license in the graphics, but they don't have any behaviors. So, for example, we might license a person, but they won't be knowing how to walk, how to react with the scene. They won't understand what particular behaviors they should exhibit. So that's obviously all of the things that we are doing.
And how do you, what kind of minimum quality do you think models should have to make them useful to people and their training data?
So that's a very interesting question. It's going to depend very, very much on use case. We've found, for example, that to do a pedestrian detector, the quality can be fairly moderate, because it's more about the position, the angle, and making sure that they are anatomically correct, and it's more about how the teaching the machine to see against different backgrounds, different lighting conditions, and so on. If you're going to go and try to do some facial recognition training, then obviously you need to make sure that you've got something which is fairly anatomically correct, and you need some fair accuracy in terms of that. So it really does depend on the use case, but actually it's sometimes it's difficult for us, because people would see something and they say, well, that doesn't look like that. I don't think that looks very realistic, and then we have a problem to sell it. But actually, from a computer point of view and from a training point of view, it makes little difference. So it does depend, but actually, surprisingly, it's not necessarily as important as people might think.
And on the subject of diversity, you mentioned there a couple of times, which is certainly something that is quite important and quite interesting here. How do you guarantee / encourage, I suppose is the better word, that there is a diversity of models? Is it just making sure they're there, or and also as part of that journey, did you find that the models were lacking in the first place in terms of diversity?
So today it's still, unfortunately, quite a manual process. It's about using your test cases, identifying where you're failing, and then trying to generate more data to overcome that. It's definitely something that we are actively researching, and will, hope that we will, start to have better solutions for than a fully manual one. So obviously, at the moment, it's down to the skill of the data scientist to make sure that the test cases that they are using are representative, review the test cases and see the failings, and then say, okay, and bias, obviously, typically people think of it as, not having enough, perhaps people of different ethnic origins in their things. But it's everything like cars. So, do you have too many red cars, which is actually throwing what the when the machine understanding is of a car? Do you not have enough pickup trucks, and that's throwing them something? So all these kind of things can be identified. But as I say, today it's a manual process, but that's definitely something that we are working on.
And this might not be a question you want to answer, I'm not sure. And also it might just show my ignorance of kind of how this could look in a real world production kind of training environment. But my experience of having looked at modeled scenes in the past, usually these sorts of things you see outside building plans and things like that. And everything always kind of looks a bit too perfect. And everyone all looks kind of too perfect. And I just wonder, do you find those sorts of consequences with these models, that everyone just looks a little bit too unlike real people?
You definitely, it's definitely, again, one of the things that is you need to be cautious of is that, everything is, clean and perfect. And as I say, one of the things, for example, is making sure that we model the cameras to model the camera noise, because obviously when you have a camera in low light, you're not picking up this clean, perfect image. You're picking up something which is noisy and has chroma speckling on it and so on. So, that's important. Okay. But you're right, in terms of the real world, if you've got 20 cars going past and you look out, I look out of my window now, out of those 20 cars, then, probably 19 of them are a little bit dirty. Probably 2 of them have a big dent in them. Probably 3 of them have stickers on the bumper. These kinds. So you're right. There is a lot of that now. There are certain things that we are evolving the simulator for to try to add more variations in that. Today we do it, but it is more of a manual process than we like. Again,
programmatic chaos.
Yeah. So it's a very good point that you make, and it is definitely something that today we handle in a way. We do handle it, but it is not nearly as automated as we would like, and that's something that is being developed right now in terms of the fixing that.
And just to clarify, I know you had a slide on this, but just to kind of go into a bit more detail, what's the kind of this? Where does Chameleon sit in the data scientist tool chain? And I guess what you listed a few on the slide. Like, is it basically just replacing that kind of manual finding of data sets, pretty much?
So we see it definitely. It's a tool, if you like, in the data scientist toolbox, because if you look at this, the diagram of the Chameleon platform, today what the data scientist does is they will get that customer's real images box down at the bottom there, and that's an image and a labeled image there that you see with the outline bounding boxes. And they'll take that to train their network. So what we're saying is, okay, that's great, but you're not going to have all the right data from that. So our data set tools there, in fact, will basically merge those real images with our synthetic images, automatically generate your test, your validation, your training data sets, and then you send that through to the neural network. They also then, the data set tools will give you feedback in terms of, okay, this is the statistics. So you've done your training and now here's the statistics, and enable you then to, again, today it's a manual process. The data scientist can look and go, okay, that's not quite right. I need some more data here, so I'll add it. But, taking the example of coronavirus, today, a data scientist has probably got a data set that he's trained faces on, and so it's okay. My face recognition algorithm works really well, and it works, great across all different ethnicities. And I can, count the number of people. But now, hey, it's not really working, or I want to actually differentiate those people with and without a face mask. we can very quickly generate our data. So that's where that augmentation comes in there.
So that's a very good use case you gave, but in as much as you're allowed to, are you able to mention any live real world cases of people actually using the tool?
So, we have got our first customers for the tool, and I can't talk about the specific use cases, but they are. So one customer is in the retail environment, and one of the use cases that they are looking at is shelf occupancy, understanding they're doing things, understanding how shelves are occupied, how consumers take items from shelves. So wanting to build a picture of the way that works. Another use case that someone has is they're trying to understand how long people go into a store for, and whether the correlation between people who have purchased something and those that haven't. And I mean, that's an incredibly complex problem. It's trying to understand, the amount of time someone goes in. It's like person re-identification, how you exactly identify, and in an anonymous fashion, what they've done. But there's that kind of thing where again, it's a combination of real and synthetic, but the use of synthetic data, because you can re-identify people, helps them with that training.
And I mean, obviously this is a relatively new product anyway, but what's on the roadmap for the next 6 months or so?
So there's a number of different things. I've hinted, obviously, we don't want to say too much publicly until they're ready. I've hinted at, there's certainly more automations coming in terms of, some of the behaviors that we've discussed, both bias and, the imperfections in the world. So there's more automation coming from that point of view. We are looking at, the visual quality as well. And actually one of, so our VP of AI strategy, Justin Bronder, who came from Microsoft, he's got a lot of expertise with this. And one of the things he's actually tasked with is trying to determine for us, well, what is required in terms of this, the very good question you asked in terms of visual quality, and where does it matter and how does it matter? But we are making, improvements in the render pipeline in terms of that visual quality.
I have one final question that is probably somewhat important to my audience especially, which is, this looks like quite a fascinating tool and something that people will possibly want to try. Is it possible for anyone just to try, or is it on appointment only? Is there a self-serve option? How can if can people try?
So today it is a contact us and we can arrange a demo. We can arrange something like that. We are considering whether we can, and it's something that I think we will do because I'm pushing it, is to open up some data packs. So to give some example images and annotations that we just allow anyone to download.
It will also help you get feedback on some of those as well. So
exactly. So that's that's definitely within the plan, but obviously we just need to make sure that we have the right structure in place. Obviously we're not a massive company yet, so we can't support 1,000 users all trying to use that and asking us questions, but we don't want to put something out there which then just annoys people because they say, well, I can't use it because I don't have the right formatting. How do I do this? I'm getting ignored by Mindtech. So we do want to do something like that, but obviously we're just making sure we do it in the right manner.
That was my interview with Chris Longstaff of Mindtech. I hope you enjoyed that. Okay, what's new? Well, I'm still working on the storytelling podcast, the Board Game Jerk podcast based on my Board Game Jerk Twitter bot, which you can find where you would expect on Twitter. We did some test recordings of that. We are working through that. I am starting the solo game live stream on my Twitch channel, which I don't think is on my website. I should get this stuff on my website at some point in the next few days as well. I'm also taking part in the Crit Test Dummies live stream, which you can also find on Twitch. So have a look there. I will try to put all these links on my website as much as possible. I have a few articles in progress. They will just keep it on my website, I think is the easiest thing to do. I need to update it. I also need to update the look and feel of it a bit. I've been struggling to figure out how to put in other sorts of content, like update content, other things I do and stuff like that. I need to have a blog for my blog, I think. But anyway, various things in progress there. Keep an eye on my various social profiles, which you can find on christianschiller.com. Please rate, review, share if you enjoyed the show. I'd love to hear from you. Again, you can find details at christianschiller.com. And until next week, thank you very much for listening.